Good afternoon to all. To all. Am I audible to everyone? Can anyone respond? Yeah. Okay. Actually, today Unit 2 is supposed to start by Rajata ma'am, but just madam was not able to take the today's class. Meanwhile, even though now I'm starting the unit number 2, my voice breaking. Yeah. Now actually, there is a power cut at my home. Now I am running this on the hot. Still breaking. Okay, this is due to the hotspot problem. Still it is breaking. I will go very slowly, but even though we will see. Okay. Okay, we will. Madam, are you taking class? Madam, can you mute your mic? Madam. Hello, madam. Can you mute your mic? Okay. Is my people are not able to listen my voice? Yes. Okay. Okay, clear now. Okay. And now today we are going to, now I will go very slowly. I will go very slowly, but there is, I'm having a separate mic also with me. But even though due to this hotspot, if any problem will comes also, I will go very slowly to today's class. Okay. Now today we are going to start the unit number 2. That is the BJTs. The BJT stands for bipolar junction transistor. Okay. Now we will see. Make chart box available. Okay, I will make the chart box here only. Now the chart available to you. Now I will start the class. Okay. Now bipolar junction transistor. Now what is a BJT stands for? In the unit number 1, we discussed the PN junction diode. Now basic characteristics of PN junction diode we discussed. And we discussed about the in details of what is the open circuit PN junction, forward biased PN junction, reverse biased PN junction. And then we came with the different types of breakdown mechanisms and the diode applications. Now these are the topics we discussed in our unit number 1. Yeah. Now we are going to see in this unit what we are going to see. What are the objectives of this unit? Now we are going to describe the basic structure of the bipolar junction transistor. Now see, this is the second device you people are studying. The first device we studied is nothing but your PN junction diode. Now the second device you are studying is BJT. Okay, in the PN junction diode also different types of diodes we studied. The tunnel diode, and different types of varactor diode, photodiode, and light emitting diode we studied. Now coming to the BJT, now first we will see the structure of bipolar junction transistor, and what we are going to do in this class is we will explain and analyze the basic transistor bias and operation. Okay, we will discuss the parameters and the characteristics of your transistor. Okay, now see this diagram. Now what is into or now first I will show you the symbol of the BJT, then I will come back to here. Yeah. Now this is the symbol of your NPN transistor you are having. In this transistor is having the three terminals. One is a base, second one is color. Okay. Now how to understand BZ that will be clearly explained with the help of the basic diagram. Yeah, tell me box. Celebrate. Okay. Completely breaking my voice continuously and lagging also. Signal is also very low. Yeah, yes, my signal is very, very low. I will be back within 5 minutes. Okay. My voice is also overlapping. I'll be back within 5 minutes. Yeah. Now my voice will be clear. Just now I got the power. I'll be back. Shall I start the class, today's class? Is it audible to everyone now? CS, please respond in chat box. Respond in chat box. Don't raise your hands. Don't raise your hands. Why you people are raising hands? Don't raise your hands. Whatever you are having, just type in the chat box. CS, please respond. Is my voice audible to you? Chat box is yes. Okay, now there is no problem with the network also. It will be back now. It is very clear. It's audible and clear. And now today, yes. Okay, now the chat box will be available to you. Now today I'm starting the today's class. Almost it was 10-20 minutes. It was delayed. Now I'm not going to take more than the 40 minutes time. Today only we plan for only introduction class today. Actual topics will start from the tomorrow next class onwards. Madam also planned today only the introduction class. Okay, listen the introduction classes because this introduction class is very useful to understand the BJT concepts. But today I will make you clear now what is a BJT, now what are the operation of your BJT, that all the things I will make you very clear today in the today's class. Okay, shall I continue the today's class? Shall I continue? Is chat box is visible to you or not? Yeah. Okay, without wasting any time, now we'll directly move on to our today's topic. Now, yeah, okay. Now first we will see what is a bipolar junction transistor and what is the basic operation of this BJT. That only today we are going to see. Right. Now I'm comparing the BJT with a simple water tap. Now just imagine two scenarios. The first scenario is now the water tank is there. Now from the water tank, water is coming to the outside. That means directly it is not coming through the tap, it is coming. Now see this tap. This tap is having now see this tap is having, this is a control input it is having. In the sense it is a valve, what you are calling as this is a control input. Okay. Now when the maximum water will flow, just this is simply equating to the real time scenario, so that you will get when the maximum current will flow through the BJT also, that just correlating to this. Okay. Now see, now here just 1 minute here, I'll come, just only 1 minute. Okay. Now is it audible? Right. Now today I am taking only the whiteboard because I am not showing you the presentation, because presentation itself it is having with some images and all. It is also not supporting today. So I am taking the pad. Okay. Today we are going to see the bipolar junction transistor that you are calling as your BJT. Okay. Now what BJT stands for? Bipolar junction transistor. What is meaning of your bi? Bi means it has a two polarities. Bipolar means it has a two polarities. Transistor is nothing but TRANS, transistor. The other name of transistor is tri-resistor. Tri means how many are there? 3 terminals. Now, if you take a transistor, now it has the 3 terminals. Okay, this is N, P, N, or it may be P, N, and P. See, first of all, what is a transistor? It is a back-to-back connection of two diodes. Now I am taking, this is a simple PN junction diode. This is one more PN junction diode. Okay. Now if you combine these two, that itself you are calling as your BJT. Now BJT is nothing but your back-to-back connection of your two diodes. Okay. Now why we are going for the BJT? Because in normal simple PN junction diode, only the single junction will be there. Now this is a simple PN junction diode we are having. And now the current is flowing through the, whenever in the forward bias current is maximum current is flowing. Okay, in the reverse bias there is zero current is flowing. But here we are not able to get the maximum current. Now for that we are going for the BJT. In case of BJT, here also the current is due to the two charge particles. One is your electrons and the second one is nothing but your holes. Okay, now the BJTs are two types we are having. Bipolar junction transistors. One is your NPN, another one is nothing but your PNP. These are the two transistors we are having. Depending upon the current flow, current direction, now we can decide whether it is NPN transistor or PNP transistor. Okay. Now before going to this, now just I would like to draw the simple the BJT construction so that you will get the clarity. This is an example. I am taking first for NPN transistor. What is NPN transistor? N and P. This is one diode. Another one is P and N. By combining back-to-back connection of two diodes is nothing but your transistor. Okay. Now it has the three terminals. The first one is, this is nothing but your base. Middle one is nothing but your base terminal. Now this is your emitter. And this is nothing but your collector. Now the names itself it is saying emitter will emit the electrons, collector will collect the electrons. Okay, this is a basic operation. Now when the current conduction will takes place in the normal PN junction diode, whenever it is in forward bias, then only the current conduction will takes place. Now in case of our BJT, now all two back-to-back diodes are there. There are four possible combinations. What are those four possible combinations? First one, it may be first one may be your forward bias. Second one is also maybe forward bias. Or first one will be in forward bias, second one will be in reverse bias. Or third combination, first one will be in reverse bias, third one will be in forward bias, fourth one will be in, both will be in reverse bias condition. Okay, now when we can get the maximum, the main purpose of the BJT is the amplification. That means if you apply a small signal at the input, output you are going to get the large signal. The best example of amplifier is nothing but now what nowadays we are seeing. Now mics, we are amplifying the signal now for the larger audience. If you are having with the help of the mic, the larger output you are able to get. Now internally the amplifier, that is amplifying the signal, small signal to the large signals. How it will amplify, that we are going to see in the present unit. That is a bipolar junction transistor. Okay, now this what I said just now, till now the BJT is having the 3 terminals. One is nothing but your emitter. E stands for your emitter. What is the purpose of emitter? Which will emits the charge carriers. Second one is nothing but your base, which is common to your 2 terminals. Now third one is nothing but collector, which will collect the electrons. Right. Now, when for example, input side I am applying the 1 volt signal. Now the output, if you want to get the 5 volts, this is the amplified one. That means 1 volt is amplified to 5 volts. This is a basic operation of the transistor BJT. Now when it is possible, means now if the signals, whatever the charge carriers you are having, if they are amplified and the more number of charge carriers comes at this point, then you can say the input signal was amplified. Okay, now what is the basic scenario? Now first we will take what is N and P. What is in the N type material, what are the majority charge carrier? These electrons are the majority charge carrier. In the P type material, holes are the majority charge carriers. In the N type again, electrons are the majority charge carriers. Okay, now see what is, and I take an example of your the same tap model. And now I show you the first presentation. One tap is, then the control input is there. Now this is nothing but your control input. So control valve is there. This is a water tank is there. For example, this side I imagine, and this side is nothing but the flow of water. Okay, when the maximum amount of water will come through the tap, when it will come maximum amount of water, the first thing is here the tank is there. If this is fully open, then the maximum amount of water will come. That is the first case. That means valve should be fully open. Now, for example, if the tank is empty, will you get, even though you are opening fully the tap, will you get the maximum amount of water? No. That means this control, this input is we are calling as your base. This tank is nothing but your emitter. This you are calling as your collector. Now, how many electrons it is collecting, how much amount of water it is collecting, it is releasing, that will depends upon the 2 factors. What are those 2 factors? How much you are opening the valve and how much water is there in the tank. Now, this is the same scenario we are equated to the normal tank model. Now, what is going to happen? Once again, I will draw neatly with this, so that I will explain here only. 10 to 15 minutes, I will make you very clear. Now, this region we are calling as emitter, base, and the collector. Biasing we will see later. First, what is going to happen, that only we are discussing. Total how many sources we require? 2 DC sources we require. Now, this I am considering this NPN transistor. In the NPN transistor, majority charge carriers are nothing but your electrons are there here. Minority charge carriers are holes. Here in the P type, majority charge carriers are holes. The minority charge carriers are nothing but your electrons. In the N region again, majority charge carriers are electrons, minority charge carriers are holes. Now see the operation. Now first we will take the combination of input section that I am calling. See, this is your input section and this is your output section. And I am drawing the symbol for NPN simply. This is your BJT. This is the current flow direction. This is your base and this is your emitter. This is your collector and this is your emitter. Okay. Now we are comparing with the two-port network parameter, two-port model. Now emitter should, at a time one terminal should be common when it is connected in any biasing configuration. Now this side we are calling as your input side. Base to emitter is input side. The collector to emitter is nothing but your output side. That means if you apply a small signal at the input, it will amplify, and at the output side you are going to get the large signal. That is the amplification process. How that is going to happen, we will see. Now this arrow mark will indicate current is flowing. Where the current is flowing, it is into the emitter. You got it? That means current is flowing. This current is from the collector. Collector to emitter. Current is flowing. Now this direction will tells you from where to where the current is flowing. Now see the first case, first scenario I am taking. I am writing the first one is forward bias and second one is reverse bias. Now this is the actual case we are going to use for the amplification process. Now what is the forward bias case here? Now when the NP region will be in forward bias, this diode, how to make this diode in forward bias? N region must be connected to your negative terminal, P region must be connected to your positive terminal, then only it is in forward bias. See, this is a variable power supply we are having. Now the name of this power supply is, now see the notation from now onwards in the BJTs, notation is very important. Now this DC source is connected between which terminals? Between emitter and base. That's why we are writing this is VBE, or you may write this is your VEB also. It is a voltage source connected between base to emitter. Okay, now come to this voltage source. Now if you want to make this junction will be in reverse bias, that means P and N. How to make this PN junction that will be in reverse bias? This side, this N is in a reverse bias case. N must be connected to your positive terminal and this must be connected to negative terminal. Then this must be in your reverse bias case. What is the name of this voltage source? Now name of this voltage source is nothing but it is connected between your base and your collector. That's why you are calling us, this is VCP, or we are calling as your VBC. So there are two voltage sources you are connected. Now one is at the input side, that is a base to emitter. This is nothing but your base, emitter and the collector. Now that's we are calling as a VBE. This is the input voltage you are supplying. And this is BC. VBC or VCB is nothing but you are connected to the second diode. Now what is the operation, basic operation, how it will amplify? That we are going to see. Now with respect to this voltage source, now what is going to happen? Now whenever negative is connected to the N terminal, positive is connected to the P side, this will be in forward bias. In the forward bias, what is going to happen? Diffusion of majority charge carriers will take place. That means all the electrons, they will diffuse into your base region. Now see why I am drawing this is, now before going to this, I would like to tell you the three things. The first one is the base region, second one is the emitter region, third one is nothing but your collector region. Now I am talking about the width wise. The base region is very thin, very small or thin. This is very width of the base is very. This is based on the construction itself. It is going to come. Emitter region is, now for example, the 100% area if you are taking, the 10% width of the base is 10%. The width of the emitter is 40%. The width of the collector nothing but 50%. Now why the collector width is more means, because it has to collect the electrons coming from the emitter as well as the base. That's why it is going to keep very high. Okay, now this I am talking about the width point of view. Now tell me what is the order you are having. Width point of which is very smaller width first. Base is a smaller width. And now what is the next smaller is emitter. Next one is collector. That means collector is more greater than emitter. That is more greater than your base. This is the order of your width of your regions. Now it has the three regions it is having. The one is nothing but your base, emitter, collector. Base region is very low width it is having, and the emitter is moderately not low compared to collector. It is lightly it is width is having. Collector is more width it is having. The second point is the doping concentration. Now for the doping concentration, base is lightly doped. It is a lightly doped. We are doping lightly to the base region. The emitter is nothing but your heavily doped, and the collector is nothing but moderately doped. Now see, because if you are heavily doping the emitter region, heavily doping in the sense more amount of charge carriers will be there. And now these charge carriers, more charge carriers will come to the P region, and then these carriers they will come to the C region, the collector region. Now see the two things, the profiles. The first one, width of the regions. The width of the regions point of view. Once again, I'm telling, base is very less width it is having. Emitter is moderate. We are not going to call as moderate also. That comes to the doping concentration. Compared to base, emitter width is very large, and the collector width is also approximately equal to emitter, but it is slightly greater than emitter. Collector width is slightly greater than your emitter. I already told you, because collector has to collect the charge carriers which is coming from the emitter, so that width of this collector is very high. Now coming to the doping case, doping concentration, how these three regions are doping? Base is nothing but your lightly doped. Lightly we are doping the base. Emitter is nothing but your heavily doped, and the collector is nothing but your moderately doped. These are the doping profiles of your three regions. Okay, now we'll see what is going to happen. Now this is in your forward bias. This connection with respect to this DC source, it is in forward bias. Now in the forward bias, what is going to happen? These electrons, they will diffuse to the P region, and these holes, they will come to the N region. And see here, the width of the base is very small. Now these number of charge carriers, they cannot accumulate in the base region. Immediately, now see the other junction. There are two junctions are there. See, this junction is nothing but your base emitter BE junction. This junction you are calling as your BC, collector base junction. Now first junction, base emitter junction will be in forward bias. Base collector junction will be in reverse bias. Now due to this reverse bias, what is going to happen? Majority charge carriers, they will not diffuse. But what type of charge carriers will diffuse? Minority charge carriers will diffuse. Now what are the minority charge carriers in the base? Now see, these electrons, whenever these electrons due to the forward bias case, they will come to the P region, they will become as minority charge carrier. Now due to the reverse bias applying at the base collector junction, these minority charge carriers, they will come to the collector region. That means all the electrons present in the emitter, they will come to the collector region. Not only 90% of the electrons. How they are able to come here? By maintaining the forward bias at the base emitter junction, by maintaining the reverse bias at the collector base junction, so that these electrons, they can come to the collector. Now how they are coming? First, initially base emitter will be in forward bias. Now I will draw this separately. Now this is my emitter and base. It is N region and P region. N region majority charge carriers are nothing but electron. P region majority charge carriers are nothing but your holes. Now you applied the forward bias at this junction. Now what is going to happen? These electrons, they came to the P region and they will become as minority carrier. Because in the P region, electrons are the minority charge carrier. Now that's why here also concentration of charge is very high in the emitter, because it has a width of the emitter is very high compared to base. Now that's why all the majority charge carriers, they will come to the P region and they will recombine with some of the holes in the P region, and that means the 10% of the, I am measuring 10% of the electrons, they recombine with the holes. And at the same time, this side, this junction we are having, this collector base junction is there now. This CB junction you are maintaining as a reverse bias. In the reverse bias condition, only minority charge carriers will diffuse through the junction. In the P region, minority charge carriers are electron. These majority, they came to this side, they are becoming minority carrier, and all these minority carriers, they can directly enter into the collector region. And see, what are the collector is? This is N material. This is the NP, and this is the N region you are having. Already 50% of the electrons are there. Majority of the charge carriers are electrons. Along with these charge carriers, in the emitter also, I am assuming 40% charge carriers came to the collector. Now, so that electron concentration will become more in the collector region. Once again, I will go through only this simple topic one. Now, see, whenever if you are maintaining input is a forward bias, output is a reverse bias case, that means if you maintain the base emitter junction is forward bias, the collector base junction is in reverse bias. In this case, it is acting as an amplifier. BJT will act as an amplifier. How it is amplifying? See, now before applying any voltage source, this is nothing but your N region. Sir, N, P, N, majority charge carriers are electrons are there. Now, for example, I am assuming here 80% electrons are there. I am taking a count of 100. I am taking out of 100, 80 electrons are there. 20 holes are there here. Now here width is here also it is. I am assuming 80 electrons are there. 20 holes are there. Because N region in the P region, it is width is very small. I am assuming total 30 charge carriers are there. 20 holes are there. 10 electrons are there. See, just for understanding purpose, I am telling. Okay, because this width is very small, with respect to the small width, it has majority charge carriers are holes only, 20 holes and 10 electrons are. Now see, due to the forward bias of the first condition, emitter base junction, what is happened? All these majority charge carriers, they diffused to this side. These 80 charge carriers came to the base region, and these 80 they can recombine with the 20. That means 20 holes are there now. All will not recombine. Nearly the 10 electrons and 10 holes were recombined. 70 electrons are there. I am explaining the scenario, but when come to the actual topic, I will explain you clearly. Now, how many 70 electrons are there in this region, base region? Now, these are the minority charge carriers in the base. The p-type material, electrons are the minority charge carrier. Now, you are maintaining the reverse bias potential at this junction. In the reverse bias, minority charge carriers they can drift through the other side. Now, these 70 charge carriers they can easily drift to this collector region, and in the minority charge carriers are the holes. The holes they can move to P region. Now, how many it came? The region in the 70 it came. Already 80 are there. Now, 80 plus 70 it is becoming nearly 150 charge carriers are there in the collector. Now, for example, with the 80 charge carrier, now we are having only 1 volt input signal we are applying. Almost is doubling at the output side. More amount of charge carriers are there. Now, that's why now this BJT will act as in this configuration. Where input is in forward bias, output is in your reverse bias case. Okay, now electron is moving from emitter to base. Electron is first moving. The base to collector electron is moving. When electron is moving in this direction, what is the current direction? Opposite direction. Current direction is from collector to emitter. Now that is what I shown you in the symbol. The NPN symbol, how the current direction? It is flowing from collector to emitter. Current is flowing through the collector to the emitter. If the current is entering into the emitter terminal, that the current direction will be towards the emitter, that is your NPN transistor. If what is the PNP transistor? Now, if the current direction is not towards this collector side, that is nothing but this is your PNP. There are two types of transistors are there. You can make two types of transistor. One is a NPN transistor. Second one is nothing but your PNP transistor. In the NPN transistor, what is this diagram? It has this is your emitter, base and collector. Emitter is your N type, base is your P type, collector is your N type. PNP transistor you are having, emitter is your P type, base is your N type, and once again this is your P type. Now, these are the two types of transistors, and once again the symbols for this will be if the current is flowing from collector to emitter. Generally, it is nothing but this is your NPN transistor. This arrow mark will decide. Now, if it is into this, then it is nothing but PNP transistor. Now, this is the simple with respect to the BJTs. Okay, now I will show you the present PPT so that you will get some little bit clarity. What I just till now I discussed. Right. Now that is what I told you. Now see here. Now this is nothing but your base terminal. This is nothing but your it is a collecting collector. This is a emitter. Just I'm imagining like this. This symbol for your NPN transistor. This is collector. Current is flowing from collector to the emitter. It is a simple transistor structure. Now see the transistor structure, how it will be. The BJT is constructed with 3 doped semiconductor regions separately by 2 PN junction diodes. This is a NPN transistor. It is a collector, emitter as well as base. There are 2 junctions are there. When we are combining three materials, now see this is the first junction. Between N and P, one junction is going to form. Between P and N, second junction is going to form. Okay, the 3 regions are called as emitter. This is your emitter, this is your base, and this is your collector. This simple structure of your transistor. Right. The BJTs have 2 types. What are those 2 types? The 2 N region separated by a P region called the NPN. That means this is an N region, this is another N region, which is separated by the P region that we are calling as NPN transistor. And second type is the 2 P regions. This is a P region, this is a P region. These 2 are separated by your N region. That is we are calling as PNP transistor. Symbols for NPN transistor. This is NPN transistor. Arrow mark will be outside. That means the current is flowing from collector to emitter. And now in case of PNP, arrow mark, it is towards to the base terminal. That is current is flowing into this. Emitter to collector current is flowing. See, in case of the NPN transistor, collector to emitter current will flow. In case of PNP transistor, current is flowing from emitter to collector. That's why arrow mark is it's showing towards the collector side. Now these are the 2 types of your BJTs. Now the PN junction joining the base region and the emitter region. Now see, this is your base region, emitter region. The junction which is joining these 2 regions, that we are calling as base emitter junction. That is what I said just now. This is a base emitter junction. And the PN junction that is joining the base region and the collector region, these 2 regions, that you are calling as your base collector junction. Now in basic BJT, there are 2 junctions will exist. One is a base emitter junction, second one is base collector junction. Now this is same for NPN and PNP also. Okay, but only the change is in case of PNP transistor, the N material is separating the 2 P regions. That is the only change. Okay, the concept of PNP transistor is quite opposite to your NPN transistor. There is a simple structure. Now if you see the epitaxial planar structure, the planar structure, it has a substrate. Under the collector will be there, base and emitter. Now see the collector width, how much area it is having. Collector area is very, very large. Now, okay, now the base region is lightly doped and very thin compared to the heavily doped emitter and the moderately doped collector region. Okay, now this is a simple values. This is simple BJTs with different types of BJTs. Now in the laboratory we are going to use the 2 types of BJTs, BC107. Okay. So these are the different types of transistor structures. Now current flows, current directions. Just now I explained the arrow is always drawn on the emitter. On the emitter only you are going to draw the arrow. Okay. Now see. Now what is the PNP transistor? If the arrow mark current, its arrow mark is into this. That means current is flowing from emitter to collector. That is your PNP transistor. The NPN transistor current is flowing from collector to the emitter. Now apply the nodal equations here. Now see what is going to happen. Now the sum of currents entering is equal to sum of currents leaving now. Now this is see. Okay. Now I will show you this with this current direction. See how it is going to be. Now see, emitter to base. Now what is emitter to base, these electrons are diffusing into this electromajority charge carriers, diffusing into N region. Current direction will be in this side. That means this current is emitter current is, it is the emitter current. And now this will show you the help of this side, then it will get clarity. Now see the current. Now how the current is flowing? The collector current and the base current, the total current is flowing through the emitter current. Okay, I will show you here. See here. Now these electrons are coming to base and these minority charge carriers coming to this collector. Now so that current is flowing from, this is your collector current and this is your base current. This total current is nothing but your emitter current. How much current is IE is equal to how much you are having? The total current, how much you are getting at this point is nothing but your IB plus IC. Okay, that is what we are going to see. This is the total current. This is okay. These are arrow marks, and while explaining the circuit diagrams. Now once again we will discuss about this current directions and all. Okay, and now these basics we will discuss in the next class. Now only just I introduced only the BJT. Now once again I am revising what I discussed just only today. First of all, we discussed about the BJT. BJT is nothing but it is a bipolar junction transistor. Now how it is constructed? It is constructed with 3 doped semiconductor regions. Now that means which is 2 regions which are separated by another region. There are 2 types of BJTs are there. One is NPN and second one is your PNP BJT. Okay. Now each BJT is having the 3 terminals. The one is a base, second one is emitter, and third one is collector. Okay. Now it has the 2 junctions. BJT has 2 junctions. The between base and emitter, one junction is that is a base emitter junction. Between base and a collector, another junction, that is your base collector junction. And in the next class, madam will discuss in detail by applying the 4 possible combinations. This is a simple BJT structure. Now for the BJT structure, by applying the biasing, in the sense by connecting the different DC sources, different possibility of DC sources, madam will explain now what is going to happen. Now I showed you today input is in forward bias, output is in reverse bias, that is the amplification process. Now whenever input side, that means base to emitter, if you are making that as in forward bias configuration, and if you are making the second output junction that is in reverse bias case, then the maximum amount of charge carriers they will come at the collector side. The current is also maximum. The input signal, small signal, is amplified as a large signal. That is a simple amplification process. Now once again, madam will discuss in detail in the coming classes about the BJTs. Okay, just I started, but due to the technical problems and all those things, I have started this class today. Now madam will continue in the next class. Okay, now this is the end of the today's class. Now we'll start the quiz. The quiz is nothing is there, only the basic BJTs. What I just told just now, based on that only the quiz is there. Now just take the quiz part and then we can take the break. Then start the quiz. Yeah, quiz started. All of you take the quiz.